Oh, it's going to be easy.
Alright, today I'm recording this lesson, so please know I'm recording. Alright, on Friday we looked at addition and subtraction of complex numbers, and we also did distributing of a constant through a complex. I think that's about all we did, right? Okay, so today we're going to look at powers. We're going to look at more multiplication of complex numbers, and we're going to look at division of complex numbers. Alright, so reminding ourselves on Friday, we defined I as the square root of -1, or actually we defined the square root of -1 as I. And so I to the first is just I. I squared. What happens when we square a square root?
It evens out.
It kind of cancels, doesn't it? So I squared would have the value of -1 because the square and the square root cancel.
Oh,
So I squared is -1.
-1.
Okay? Now take a minute to not talk, to just think about this. And those of you that are taking notes, I cubed is our next one. Would it be fair to rewrite I cubed as I squared times I?
Yes.
Does that have the same value? Okay, I squared we just defined as -1. So -1 times I is -I. So I cubed simplifies to -I. Let's talk about how that happened one more time. I cubed is I squared times I, because I is really to the first power. And when you multiply like bases, don't you add the exponents? Okay, so we see how these are equivalent. Well, I squared, we just said had a value of -1. I to the first is just I. So -1 times I is -I. So I to the first is I squared is -1, I cubed is -I. I to the fourth. I'm going to go with the same idea here, but I'm going to write it as I squared times I squared.
No way.
Because when we multiply like bases, we add the exponents and we get the 4. You see how those are equivalent? We said I squared was -1, and -1 times -1 is 1. Okay, so I to the first is I squared is -1, I cubed is I to the fourth is 1. I to the fifth, we can rewrite as I to the fourth times I, can't we? I to the fourth, woohoo, 1, and 1 times anything, it's just that thing. So it's I, because 1 times I is I. Okay? I to the sixth is I to the fourth times I squared. Okay? And I to the fourth is, yes, you got it, is 1. And I squared is -1. What's 1 times -1? -1. Okay?
Oh, so it's like
Alright, it is a pattern. It is a pattern. So Lauren's got it, Noah's got it. Abby, what's the next one going to be?
Well, why are some of them numbers and some of them eyes? Like,
Well, we're alternating in
got
between real and imaginary.
That was -I, and the next one was 1.
So it's just like.
Oh, Carson's got
Oh, I remember
it.
the pattern.
And then what's this one going to be?
That one's
I,
And then
and then
-1,
-1,
Negative I.
negative I,
and then 1.
and then 1.
I gotta need you to do the work.
Does everybody see that it started out I, -1, negative I, 1. I, -1, negative I, 1. I, negative I, 1. It is a pattern. And it repeats every 4, doesn't it?
Whoa.
Yeah. Okay. Now, some of us like mnemonics. And if you do, here's your mnemonic for this one. I won! I won! See? It's I won. I won. And the 2 in the middle are negative.
Mind blown.
Wait.
Okay, so if you like a little cutesy thing to help you learn it and not really know why, that's it. But here's the why. I like the why better than the cutesy. Okay. So, you may not. But there it is.
Watching on YouTube.
So, this is kind of nice. that it repeats every 4 because it helps us do things like this.
How did I stay?
I did the 37th.
Oh, jeez.
Okay. Who's got an idea?
I do.
Hang on.
I got it.
I got it.
Multiply by 4. Or like. What?
It's
I
I.
got it. Yep, it's I.
It's I.
Just add 4 every time.
It's I or negative
Possibly
1.
it is I.
It is I. Okay. Okay. I saw some light bulbs. I saw some almost theirs. You know it's going to repeat every 4. So it goes through this pattern completely 9 times. Right?
4 times.
And then there's 1 left over. So it's like I to the first. Goes through the pattern completely 9 times. And then there's just that 1 left over. So it's really just I. You ready? Here we go. I.
Pledge allegiance to the flag.
Are you okay?
No, he's not. I'll go ahead and answer that. I to the 83rd.
Okay, no, we're not.
What's
It's going to be a negative I.
It is negative I.
It is negative I.
No, you messed up
It
again.
goes completely through the pattern 20 times.
Oh my goodness gracious.
And there's 3 left over. And I cubed simplifies to negative I.
Oh my.
That is so
Okay? Alright. I to the 216th.
Fun.
I don't know how to. That's going to be a 1.
Oh, it's a 1. Or I.
It's a I. It's a I.
I.
It's a 1. It's a 1.
I got 1s, I got I's.
Oh, wait, no, it's
Right.
It's 1. Because not divisible by 4.
Easy, easy.
It's 1.
It is 1.
Right.
And there's a couple different ways you can think about this. You can think about it going completely through the pattern 54 times. Or you could say, hey, when I divide this, it's like it has a remainder of 0. And what happens when I raise something to the 0 power? I get 1.
Something goes through it like perfectly. I'm stunned. My
Anything lands on
Okay. So, we're going to integrate these powers of I into our other problems. A lot of times we're just dealing with the first couple, but sometimes we like to make problems more interesting and more fun, and we use some higher degrees. Okay, so we're going to start with some multiplication examples. We have some on this page, so we have about 5 of those. Then we're going to do 3 division problems, and then we're going to do our homework, because that's a good thing.
Yes.
All right, so these are our examples. Take a moment to copy them down, and then we'll talk about them.
Can we do it first, just because?
We haven't worked on that.
You know what? If you can, more power to you.
Isn't it just 2 the same as
I have taught you all you need to know.
Does the square
So we're done for the year?
No.
Some of you might be.
Oh, dang. Not me.
I dropped out tomorrow, I would be. I'm not gonna. I understand this.
I went to a conference one summer and they told me that sarcasm is not good.
But
And I thought, wow, that would ruin half of what I use in the classroom.
yeah.
What shall I do? So, I just ignored it.
Yes.
Alright, so we're going to distribute, right? So we're going to do 2y times 3 is 6i. Alright, and then we're going to do 2y times the negative I is negative 2i squared. Alright, but we just learned we can simplify I squared. We know I squared is negative 1. And we multiply negative 1 times anything. Doesn't it just change the sign?
Yes.
Okay, so since I've come to that realization that multiplying by negative 1 just changes the sign, wherever I see the negative I just change the sign. I mean, excuse me, the I squared, I just change the sign. Okay? And I could leave my answer like that, except it's not the form of a complex
That's what I've
number,
learned.
which is the a plus bi form.
Negative 2.
So we're going to throw that 2, which just became positive, out in front.
Minus.
And so my answer will be 2 plus 6i. Okay? So that's when we distributed imaginary through a complex. Now remember, the imaginary numbers do fall under the complex umbrella. They just have a real part of 0.
Just go to, you go to A plus BI.
No. Because you know what that won't
Oh,
do.
no, I don't use it. I just found
They have already discovered that your calculators have a complex form mode. Yes, they do. But I have also discovered that, and I know what your calculator won't do. So guess what's on your quiz? Those problems.
Yeah.
All right. So here we go.
Wait, we haven't finished that.
Okay, we're going to distribute here. I'm going to take this first complex number and I'm just going to focus on the real part. I'm going to distribute the real part through the second complex number. 5 times 2 is 10, and 5 times 4i is 20i. Then I'm going to go back, and I'm going to take the imaginary part of the first complex number and distribute it through the second complex number. So I get negative 2i minus 4i squared. But just as I squared up here changed the sign, I squared here will also change this to 4 times a negative 1, which make that a positive 4. Now we're going to combine our real parts, just like we did over the weekend on our homework. So we combine our real parts and we get 14. We combine the imaginary parts and we get a positive 89.
So good at this.
I got the answer.
So the product of those two complex numbers is this. All right, you try. This is a product that is written as a binomial square. You have 3 different ways to solve this. Well, to simplify this.
Is it 10?
Choose one of them.
Is it?
No, the answer is not 10.
Yeah, you might use that term.
You don't have to.
You can.
We had a little chant also.
Oh, wait. Square the first.
I got that.
Oh, didn't actually.
Hey.
Yeah.
Square the first, double the second. Square the last.
Double the profit didn't change.
Square the first, double the front, square the last.
Change the chances
Square the
Product.
front, double the front,
I
square
don't
the
remember.
Hey.
first.
Oh, I'm a failure. All y'all can remember is
Hey.
Square the last. Yeah.
We got
Hey.
double the product.
Product.
Is it square the left? I don't remember.
Hey.
I got you.
Why do I remember this on the
Yeah.
test?
YouTube's gonna be here singing. You listening to him from YouTube, get it to 1,000.
All right. You're right. It is square the first and double the product of those 2 terms and square the last. So we squared the first, you're right. We get 9. The product is negative 15i. If we double that, we get negative 30i. And when we square the last, the negative 5 times squared becomes a positive 25. But we also have to square that I.
Square.
And squaring the I really turns us right back into negative. Correct? So we're going to combine the real parts. 9 plus the negative 25 is negative 16. So it's negative 16 minus 30i. Now, of course, you didn't have to do it that way. You could have done Pascal's. There's no way I would on a binomial square. If I'm just squaring.
Yeah,
But you could.
I'm confused.
Yeah, I would get that.
Shouldn't it be like negative 5 times
we did it
squared to get like negative 25, and then it would become plus 25, so it'd be 9 plus 25?
Hey.
Not minus 25.
Okay. When we square the negative 5, negative 5 squared was positive 25. And we also had to square the I, which was the I squared. So, okay, let's write it out twice and take a look at it this way, and maybe it'll be a little more clear.
I got it now. Like,
You got it?
Yeah,
Okay,
I got it.
Wait, what?
You can do that?
Oh, sure, you can do
Wait a
this.
minute. What? If you double, if you square the last. Oh wait, no, never mind. I squared it wrong.
Alright. Here it is. If you write it out twice and you just distribute, you can certainly do that. That's why I said I would never use Pascal's on this. I would either write it out twice or I would square the first double product, square the last.
Hey.
Right. That's right.
You can have the headache.
Oh boy. So, either way, this negative 5 times negative 5 makes a positive 25, but the I squared is going to turn that right back into a negative 25. So, that makes, at this point, I can't even focus.
I don't think any of us.
Hey.
Alright, you
It's
go.
Monday.
Alright, no more haste.
I don't like Monday.
No more haste. Okay, we
You
gotta
know
get
the
through
movie
this.
filled Monday? But there's no movie. Shh. I'm sorry.
Alright. Any questions about this problem? Thank goodness. Alright, next problem.
Oh, goodness.
3i to the 7th, which is not a big deal now.
Negative I.
Minus this, plus that. And I'm giving everybody that likes to take notes an opportunity to do that before I move on and go too fast.
This is easy, easy lemon squeezy.
Okay, my approach does not have to be your approach, but my approach is to simplify the higher degrees first, and then I'll distribute. So what I do when I look at this is I go, okay, I to the 7th is the same as I to the 3rd, which is negative I. So this is 3 times negative I, which is negative 3i. Now, in my work, I would go straight from there to there, but I wanted you to see my thought process. I to the 7th is the same as I to the 3rd, and I to the 3rd is negative I. So this simplifies to negative 3i. Did you follow that train of thought?
Yes.
Okay. The 2, there's nothing to it. This is I to the 3rd, so this is like negative 5 times negative I, which actually makes a positive 5i.
Oh, no distribution.
Okay? I squared is just like negative 1. So this becomes minus 1 times 4 minus I.
Could you like use distributive property?
Sure, you could distribute to start with.
That's what I did.
Huh? You might have a chance of getting it right too.
Oh, you have a better. Yeah, you don't have to work as much.
Okay.
But, yeah, you do.
Well, it's probably super wrong.
The answer's probably super long. I don't know.
Okay. So we're going to distribute the negative 3i here, and that's where the negative 6i and the negative 15i squared come from. I'm going to distribute the negative 1 here, and that gives me the negative 4 plus I. Now, the only thing left to simplify is right here. That I squared turns that into a plus 15. And so when I add the real parts, 15 minus 4 is 11. When I add the imaginary parts, negative 6i and positive I results in negative 5i. So this simplifies to 11 minus 5i. Okay, everyone, this is your you try. I'm going to come around and answer questions to those people with their hands raised.
You get the same thing with
What's the little
distributive
quotation
property.
thing? Oh, that's 11.
That's an 11.
I got close.
74.
I got like about a 7.
I
Isn't
think
that
right
supposed to be a
now.
negative I can?
Right.
Because it's an addition to
74.
it's terrible.
There was a negative 1 out in front. I had to distribute it through there.
You'll take out two.
Oh, it's
Let's push it. So drop that. Change it towards negative, but you distribute it to them.
I choose
What
I changed
So it's negative I.
because I distributed that out instead of did it your way.
Minus 7i.
I squared
18
by
and a half.
I.
Oh man, my 4 goes in
You can't
there.
simplify the exponents to start with, but your answer should match mine.
And then you do 18 divided by 4.
But my argument is that
I to the second.
when you're multiplying I squared times negative I, that's negative I to the 3rd, right?
Then you have negative I to the third, which is the opposite of negative I, which is
That's
positive
where
I.
I messed up. Dang it.
It's 2.
It's not even cool.
Oh, no,
You're
no.
mean. It was too hard of a question.
They're easy weezy.
Oh, God.
Like, I'm already almost done.
It is my job to challenge you.
Negative I 2 minus.
Alright, now what's
So who's her
I
answer?
to the 11.
So they're done. Be like to the second.
I have the answer. I'm done.
74. Are you guys the 11-1?
No?
I the 11-1.
Oh, probably this one.
It's I the 11-1. It's I the 11-1.
Wait, why did
No, probably not.
What'd you get? What'd you get? What'd you get?
Negative 1.
It's I the 11-1.
Wait, whoa. That'd be +2.
Did you get regular five or negative five?
Minus!
We just need to calculate it.
That's
not what I got.
Pattern evenly 20
I
times.
think I did it.
And then there's a 3
Oh, what did you
left
get?
over,
Five?
which is
It's just 4.
down.
It's just 4.
What did you get?
Colin,
I
what'd
got
you get?
5.
Five?
This one gets
I got 5.
Oh, I forgot to.
Did I get it wrong?
I got 4.
at the end of
What'd you get?
I think I got it.
Don't worry, at first I got -9, so.
Oh, that's where I
Or I
missed
squared.
because I did 0.
Wait a minute!
Wait, I squared
Ah,
what?
really
Negative?
screwed up. I screwed up.
Okay, it's -1, so it'd be -14.
I got 7, I plus 12.
I got
We need like
royally
like
wrong.
like
So did I.
We're right.
7 I plus
12.
I'm
both of us
not
were like
confident.
like both of us were like
7,
7
9 plus 12.
I had like 9,
7, 9 plus
12.
7.
And if you give it to give
It's
her.
5.
Sure, it's not square.
It's 5.
It's just 5.
5 is squared.
Oh,
Yeah, they're pretty easy.
It's not gonna be that strong.
All of the power.
I got 5.
7 I squared.
Alright, so you go over it real fast.
No, we had
5?
got the same answer.
It's
It was
I.
No, I.
I know.
Yo, that's what I'm gonna
That's
say.
it.
7 I
That's
squared.
it.
I will.
Okay. Alright. Let's do it. Okay, I'm not going fast, but I need you to be quiet and let everybody understand. When I divide 11 by 4, what is the remainder? 3. So this simplifies to I to the third. And I to the third is negative I.
I did -1.
Okay, do we get that?
Yeah.
Alright. So that was step 1. Okay? This is -2 times I to the 74th.
Which is.
The remainder is 2, isn't it?
Oh, that's what it is.
The remainder is 2. So that's like I squared. Well, I squared is -1. So what's -2 times -1? Positive 2. Okay, so that's the first thing we're going to do is simplify those higher powers. Then we're going to distribute and we get -2i plus 7i squared plus 12 plus 2i. Okay, so my imaginary parts
Oh, wait a minute.
cancel.
Oh.
I did that.
This becomes -7, and -7 plus 12 is 5.
It was already -7.
Yep.
Oh, that's
And
I
then
didn't
why
even-
is it?
Okay, so.
Oh, I squared, so it's either side.
Yes.
Negative. And then -7 is 12. Or 5.
Yeah.
All right.
Negative 7.
Wait, I got the answer.
The answer's 5.
I got that answer.
Isn't math
I would
kind
do
of
correctly.
cool how we can go from this?
I didn't
Five?
distribute it properly though. That's how it was easier.
This is crazy. All right.
I got it right.
These notes will be on my website if you guys want to look at them later. Now, the last thing we're doing is division. You can see all the examples right here. 3 examples in a year. No, division is not hard. Okay.
What is it?
Now,
Oh, that's easy.
we defined I as the square root of -1.
Okay.
Okay. So this looks like a fraction, right? Division kind of looks like a fraction. Are we allowed to have a radical, such as the square root of -1?
No.
In the denominator, no. So just like our rules with radicals said we can't leave a radical in the denominator, we can't leave an imaginary number in the denominator. So if it's just imaginary, or if it's part of a complex, it can't be left in the denominator. So we're going to do this division. Now, we're going to... Max, you okay? Like, I'm not sure. I'm not sure about that. All right, now,
You don't have any 11 numbers.
Let me ask you something. If I multiply this by -1 divided by -1, isn't that really just multiplying it by a value of 1?
See?
So it's not going to change the value of this at all, will it? But it will change what it looks
You
like.
just cross out the eyes.
Because what I'm multiplying by has a value of 1. And multiplying by a value of 1 doesn't change anything. Except maybe the form. So it's going to change how it looks, but it doesn't change its value. Now, let's multiply the denominator because it's the easiest. I times negative I is negative I squared. Okay? Alright, now let's multiply the numerator. That gives me negative 4I plus 7I squared. Okay, normally I just cancel it out and put a plus, but isn't there an understood 1 right in front of there?
Yeah.
Okay, so when I do cancel this out, because it's like multiplying by -1, so it changes the sign, didn't my denominator just turn into 1?
Yes.
Oh, how nice is that? Okay, and now this is going to make that a -7. So I really don't even have a denominator anymore because it's 1. So this is -7 minus 4I when I write it in A plus BI form, which is the form for a complex number.
So what if we have more
Wait, wait,
than
I have a better
I
choice.
on the bottom?
So do you just, I guess we'll figure that out.
It's going to get a bit harder.
Not really.
Where's flippity?
Okay, maybe this one's a little bit, not a big deal though.
Okay.
Okay,
Oh.
now, are these two things conjugates?
Conjugate negative I.
Yes, yes, yes.
Yes, they are. So, let's see what happens when I take any complex number. I'm going to let A plus BI represent any complex number. And what would the conjugate of this be?
Negative A. Oh, wait. A minus B.
A minus BI. So when I take any complex number and multiply it by its conjugate, okay, I'm going to go slow. A times A
A squared.
is A squared. A times negative BI is negative ABI, which would be awfully confusing except what's about to happen. Positive BI times A is positive ABI. And positive B times negative BI is negative B squared I squared. Okay, now I squared does what?
Square everything.
Changes it to
Positive.
positive. What happens to my opposites?
They
cancel.
out.
And so did all the imaginary parts go away.
Yes.
Every time I multiply a complex number times its conjugate, the imaginaries disappear, which is very helpful when you're dividing. If you multiply the numerator and denominator by the conjugate of that denominator, it eliminates any imaginary part from the denominator. Every time. This is why we just proved it. We proved it. Every time we do that. Okay.
Wait, so you would just do like the opposite of the denominator?
Can you show us?
Yes. Yes, I will. Okay. So, this one we could multiply both by -2i. If it's just imaginary though, guys, negative I will work. If it's just imaginary and not complex. Okay?
What do you mean?
Okay, watch. If it's just
Oh,
imaginary,
instead of like.
Okay, so evidently I have one last announcement to make, and that is for the JV softball practice. Will not be at the softball field today. Instead, you need to meet in the art room at 4 o'clock. That's for JV softball. And once again, you guys, thank you so much. It's been an honor. I love you. And go Stars now. Bye.
she did not cry that time. Alright, we still have a few minutes. That was real early. Okay, I'm going to show you. This is 2 plus I.
Wait, did you not
This is
say
2 plus I.
Did you not
Yeah, I'm done with the first one.
Did you not say
Okay, I can't stop. You gotta watch. Alright, so we're gonna multiply here. and we get 4 plus 2i minus 2i minus I squared. Every time, these two cancel. Every time. I squared is negative 1. So minus negative 1 leaves us a 5 in the denominator. We eliminated every imaginary number. The numerator, it's not going to happen so nicely. The imaginary numbers are still there, but it's okay to have one in the numerator. Just like it was all right to have a radical in the numerator. This I squared is actually negative 1. So this leaves me 5 plus 5i. Well, because the denominator divides into both of them, I should.
Cancel.
So 5 goes into 5 one time. 5 goes into 5 one time. My answer is 1 plus I.
Alright, you did video this, right?
I did.
And I'm gonna watch it.
Okay. And then this one I'm going to show you. I'm not even going to talk. So maybe I can get it before the bell rings. This is what we do. The denominator, I don't even have to do the outer and inner because I know they're going to cancel every time. Okay? That's going to make this plus. I'm going to distribute the top, and it gives me 15 minus 30i plus 6i minus 12i squared. The I squareds cancel. I have 27 minus 24i over 45. 3 divides into everything, so I get 9 minus 8i over 15. Now, there are some textbooks that make you split it. Ours does not. Schools of thought vary on this. I'm okay if you don't split it. If you did split it, this would reduce some more to 3/5. This is truly an A plus BI form.
Do we have any homework?
That's on your calendar.
Alright, I'm sorry.
Nope, it's in your vote book.
Is the geo book the green book?
It's in your Geo Green Book.